Hello, and welcome to this video tutorial by OpenTopography. My name is Chelsea Scott, and in this video, I'm going to discuss how we can locate tectonic faults in a digital elevation model. Here's an example of a digital elevation model spanning the central San Andreas Fault in California. So in this video, I'm going to discuss briefly what a digital elevation model is, and then hillshades, and then we'll look at two examples of hillshades along the San Andreas Fault. So a digital elevation model is an example of a gridded or raster data set. So this is a digital representation of the elevation or the topography at the Earth's surface. On the right, you can see an example of a raster or gridded data set. Along the edges, we see zero elevation, here where all the zeros are, and at the center is 400. So this is an example of a pyramid. And as you can see here, a raster format is a data set that is a grid of squares. And each square has an elevation or a z-value. And it's important to note that these are really 2.5-dimension features, not true 3D. So features with 3D structure, for example, trees, cliffs, or overhangs that have more than one elevation at a single location at the ground surface, these can only be represented by one single elevation. So that is what makes these 2.5 dimensions. So here is our example of the digital elevation model in California. And here you can see how this is colored. The low elevations are in black, for example, at 440 meters. And the high elevations are in white at 520 meters. So here we can see low elevations here, and then higher elevations here. Here in the next slide, we're going to be looking at the location of the mapped San Andreas Fault, which is the line work shown here in blue. We can go back to looking at our digital elevation model, and we do see a subtle step here where that blue line is, but the location of the fault really doesn't jump out at us. So the secret is to make a topographic hillshade. So we already have a few videos of how to make these topographic hillshades. So I will recommend that you watch those videos if you are interested in learning how to make a topographic hillshade. But in brief, a hillshade, which can also be called a shaded relief map, is a representation of the terrain that is created by casting shadows from a light source. And this light source has an azimuth and an altitude. So the azimuth is a cardinal direction, and it is written in angles. So for example, from 0 to 360. And then the altitude is also an angle ranging from 0 to 90. And it's really important to appreciate that the light azimuth impacts what is seen in the landscape. And what you'll see is features that are perpendicular to the azimuth of the light source. And it's therefore really important whenever you're making hillshades to make at least 2 hillshades with azimuths that are perpendicular to each other, as this will let you see things quite well in the landscape. And to see things even better, I recommend creating hillshades also with different altitudes. So we're now going to look at two hillshades from the same area. So this first one that we have here is with an azimuth of 315 degrees and an altitude of 45 degrees. So we're going to be able to see features very nicely with a northeast or southwest orientation. For example, we can see these channels very nicely because the wall of that channel is approximately perpendicular to the 350 azimuth angle. And here is that perpendicular hillshade. So it has an azimuth of 225 degrees and an altitude of 45. And here, the approximately linear feature that we see in a slightly lighter gray color, this is the San Andreas Fault. And it is that lighter white color because it is facing the azimuth of 225 degrees. And so here we can really nicely see, we could map the trace of the San Andreas Fault. And just to reiterate, here's the other topographic hillshade, and we really don't see the fault nearly as prominently as we do here. And so this is why it's really important to create at least two different topographic hillshades to be able to visualize the landscape. And a tip is that when you're making these hillshades, it can be really easy to forget what their azimuth and altitude angles are. So I recommend that you always name your hillshade with those numbers. For example, here we're on the San Andreas Fault, which could be abbreviated as FAF. And then we have the hillshade azimuth of 225, altitude 45. And so with this, then we can always come back and know what the hillshade is representing and what it's not representing. Thank you for watching this OpenTopography tutorial.